So there are a couple of things you have to know when you start programming for 3ds authentication. So if you look at this documentation here, the most important thing is how the key values are stored. So the documentation refers the keys as the key 1 and key 2, whereas key 1 is 8 bytes and key 2 has 8 bytes as well. So in this example, as you can see here, the key 1 is 00, 01, 02, 03, 04, 05, 06 and 07, and this is the value we are going to use for the encryption and decryption. So when you send the 16, when you use 16 bytes in the 3ds algorithm in .NET, you use this key as it is in the same order, starting from 00 and ends with 0f. However, when you try to change the value of the key in the ULC tags, you have to write this in the reverse order. And as you can see here, say the key 1. So in page number 44, so you got key 1 slash K0, key 1 slash K1, and K2, K3, and so on. So the K0 refers to the 07. Yeah, as you can see here, so in this case, so the value that is stored here is 07, 06, 05, and 04, and this goes into the page 44, and the next 4 bytes is 03, 02, 000. So if you consider this as an array, then before you save, you can reverse the array. So there are many .NET array functions you can reverse the array, and so when you reverse this 8 bytes, you can take the first 4 bytes and save it in page 44, and the second 4 bytes and save it in page 45. Similarly, the key 2 starts from 08. While saving, you have to reverse this 8 byte arrays, and you'll end up getting, so as you can see here, you'll end up getting the 0f is the 0f here. That's the first byte, 0f, and 0e, 0d, 0c. The first 2 bytes, the A2 and A2 and 2e. A2 refers to the write command, and 2e refers to the page address. So likewise, so after this, if you scroll down, so this example clearly shows how these keys are stored in ULC. So it's very obvious from this diagram. So just keep in mind when you write or when you want to change or personalize a ULC tag, you have to write the keys in reverse order. But when you use the keys for encryption decryption, you have to use them in the proper in the standard order. So that's exactly what you see here. So in this diagram, so the keys that are used for encryption starts from A8, A7, A6, and A1. However, when they're stored as A1, A2, A3, A4. So I've done exactly the same thing. I reversed the array and I use that reversed array for writing. So similarly here, the key 2. So the value that is used for encryption decryption starts from B8, B7, B1. However, the way it is stored is starting from B1. And in this screen, I've also given it's a small utility, a tool where you can also set the keys either by modifying or entering hexadecimal value, or you can also write say A, B, C, D. So you can make all capitals. So say B, C, and D. As we enter this ASCII here, the corresponding hexadecimal is entered here as well. So E, F, G, H, I, J, K, L, M, N, O, and P. So I can change the keys to this if you just select the tag again, and I can, if I hit this right button, so I'm going to change the keys to ABC, CD up to okay, so write it. So now I've changed the keys to this. So let us try to authenticate. I'm going to select this tag again. So if you set this a factory key and try to authenticate, because in the first step, no keys are used. So everything changes when you start decrypting it. Okay, so what we did was, it is at this stage where the key was used. So we decrypted using this factory key, and you again encrypted using the factory key. So when you send this to the ULC is not able to recognize. So the ULC doesn't return you 000. However, this is my program returning 000, and actually this is wrong. I just have to ignore that. So when you get all 00, that means the authentication did not go well. So you have to try again. Whenever the authentication fails, and if you look at this somewhere in the documentation, you have a diagram here. If you just scroll up in the documentation, there's a nice flow chart, and this is worth going through once. So when authentication fails, as you can see here, so this will take you directly to the halt state. Okay, so it's this one. So that's exactly what has happened now. So we tried to authenticate, but it failed. It went to halt state. So whenever it goes to halt state, so as the diagram says, you have to again start from WPA command, which is again something like a select command. So I'm going to select this tag again, and this time I'm going to quickly change to A B C D E F G H I J K L M N O and P. So let us challenge now, and the decryption encryption has happened using this new key. I'm going to again send this encrypted thing to ULC. ULC, okay, because ULC also stores the same key. So you got back, the encrypted value of RNDA, which again, so as you can see here, so these two matches. So that shows, it worked. So that's all about 3DS authentication using ULC. But keep in mind, if you ever want to try ULC authentication, don't forget to buy the PN532 card and buy from ADF Root. You get a good support. They are very professionals. They help you a lot. So that's it.